right? So this part is du dx. Now this part, how do I get that one? This part I want to write it, I hope to be able to show that this is dy du. So, how do we explain that? I can't explain it. I can't explain it clearly. I want to write this as dy du, this one here. This is, y is that, so it's, and I'm asking for the derivative, so that I can see why I call it dy, but why do I write du on the bottom? Suppose I had this, y equals f of u. If I had that, and I want to write the derivative of y, how do I write it? If I use this kind of notation, how do I write it? I would write it as dy du, right? Because this is not x, so I don't put x there. This is u, so I write du, right? What does this mean? This means that when you change u by a little amount, we're asking how does y change, right? That's what dy dx means. That's what dy du means. It's like a rate of change. So, I'm almost there, but, so this is dy, I can't quite say it. I don't know, maybe you can see it. But let's look it up on the internet and see if we can find a better explanation. But anyway, we can write it like this, okay? And that's the other way to express the chain rule. So this is one way, and this is the other way. All right? So here, it kind of looks like these are canceling, but it's not really canceling. Because those are not individual pieces, so you can't cancel them. Okay, this is just a single notation. Okay? All right, let's see if I can find that. Let's see. How do I look it up? Okay, let's look at this. Here's the chain rule using the prime notation. So here's the notation that we started with, right? Everyone recognize that? Oh, actually, they're doing G on the outside and F on the inside. So it's G prime on the outside and F on the inside and F prime here, right? But that's just the same thing, but we just did F of G, they're doing G of F. Okay, everyone follow that? Now, they say the function u equals f of x expresses the dependence of u on x. So u, we're saying, is like the intermediate variable. Okay, we're just calling f, calling that u. Okay, we can do that. Okay, expresses and this statement expresses the dependence of u on f, right? This says that u depends on f. So the rate of change of u with respect to x is the derivative is f prime. So that's du dx. Okay, now I did that part already. This part is the part I got stuck on. The function y equals g of u, because u is equal to f of x, so this is g of u here, right? That's g of u, right? Okay, so g of u, which we'll call y, expresses the dependence of y on u, right? This expresses the dependence of y on u, right? Okay, so the rate of change of y with respect to u is g prime, there it is, g prime of u is dy du, right? And that's just what we mean. We're just doing the derivative of this is dy du, so we have this, right? Everyone follow that? Okay, but that is g prime of u. That's the trick that I didn't quite get, this part here. That's g prime of u, but g prime of u means what? G prime of this. So that's this part here. Okay, so this part is this part, and this part is this part. So we end up with that this, the way I expressed it in class, is the same as this, or rather is the same as this. Okay? So you can go back and look at this again. Okay, but so this is the chain rule in using the Leibniz notation. This is called Leibniz notation. We write the derivative like that because there's a guy named Leibniz in Germany who they say discovered the calculus, the theory of calculus, at the same time as Newton did in Britain. So they didn't develop their same notations. So he used this notation, and Newton used this kind of notation. Okay? But they were working on the same ideas. So anyway, this is the chain rule in Newton's notation, or the prime notation. I don't know if that was Newton's notation. And this is the chain rule in Leibniz's notation. Okay? All right. Now, why do they call it chain? So I said this kind of looks like a chain, but there's another way to say that. Let's look at this, just to kind of explain why they have the chain, why they call it the chain. Whether you prefer the prime or Leibniz notation, it's clear the main algebraic operation in the chain rule is multiplication. That is here, this multiplication here. In order to illustrate why this is true, think about inflating a sphere. So here's a sphere and it's a balloon, you can blow it up. Okay? Air is pumped into the balloon and the volume and the radius increase. Right? Both the volume and of course the radius increase. Both the volume and the radius are functions of time. Right? As you blow it up, over time, the volume increases. The volume is a function of time, and radius is a function of time, right? Okay, the volume formula for a sphere also expresses the volume as a function of the radius. So we know that volume is equal to this, right? Right? Volume is equal to that. But on the other hand, R is a function of t, right? Right? So we have volume as a function of r, but r is a function of t. That's just like here. This is v is a function of well, this is v is a function of r, but r is a function of t. Okay, maybe I'm getting, anyway, okay? So we have this kind of relationship. T goes to r and goes to v. So that means that the change in volume over time is equal to the change in volume with respect to r times the change in r with respect to t. Okay, so this is a kind of a chain effect. Okay, a chaining of effects. So someone was working with this kind of problem, and so they called it the chain rule. Okay, so one thing affects another. So you get this chaining of effects, and that's what this does. It says that the change in the volume over time is equal to the change in the volume per radius change times the radius change related to the time change. Okay? So it's that kind of thinking that gives maybe where they started to use this. And anyway, that's where they came up with it, calling it the chain rule. Okay? All right, any questions about this? Okay, one more. How about what's this? What's the derivative of a constant? Oh, constant, what's an example of a constant function? F of x equals 10. F of x equals 10, not f of x equals 10x. Not f of x equals 10x cubed. Just f of x equals 10. What does that mean? That means for every x, no matter what x you put in, you get what out? 10, right? So that's a flat line, right? Okay? So what's the derivative of a flat line? It means what's the slope of a flat line? 0, right? Okay? So what's the derivative of a constant? 0, right? So this is the picture, right? Here's y equals, I guess this is what? What's going on here? Oh, this is y prime, I'm sorry. This is y prime, this is y. So I guess that's not a good picture though. Let's try this. So rules of differentiation. So I skipped this one, but this was the easiest one. So we have a bunch of rules, right? We have the sum rule, right? The addition rule. We have the subtraction rule. We have the multiplication rule. We have all these rules, but I skipped the easiest one, which is the derivative of a constant is just 0. Okay? So we can always keep that one as well. Okay? Any questions about this? Okay, so we have done, I think, all the stuff we need to do for finding derivatives. Okay, so so that's, okay. So now, let me do one last thing, which I forgot to do before, and that is, let me look at your grades. And let's see, let's look at this. So I just want to look at whether everybody's doing okay or not. So let's go to all of the assignments. Past assignments, I guess. Okay. Okay, so some people that true? Okay, so some people don't have very high percentages here. Okay, so let me tell you something. So I think I mentioned, but let me tell you again. So if you go to if your grade is low, you can get more points towards your final grade. So if you go to the AMC Center, every time you go there, you can, I'm changing the rule. I said it was 0.5%, but it's 1%. So every session you go, you can raise your grade by 1%. So the AMC, it's called the Analytics Math Center, is just across the walkway in the library. And it's you go into the library, you turn left, you walk past the front desk, and just after that, there's a couple of booths there, and there are some tutors there. And if you bring them questions, they will attempt to answer them with you. And each period, there are 2 sessions, and you can go in and just walk in there, but if somebody's there, of course you can't kick them out. So you can also figure out how to register online, reserve a space online, a time slot online, but it's easiest if you just go over there and then they'll show you how to do that. And you can, as I said, every session you go there, every half a period that you attend, you can bring up your percentage grade by 1 percentage point. Okay? But you have to get a slip signed from them and give it to me for each one that you do that. Okay? So I'm looking at these percentages, and I thought I looked at them before and they weren't this low. But right now, I'll just show you without giving anybody's information away. I'll do that. So according to this, according to what I see here, according to this, unless I've done something wrong, oh, sorry. These are people's scores. So if you recognize your ID, you should maybe don't show that on the video.
Yes, it's not on the video.
Okay, there they are. So you should try to bring these scores up. Okay? So I hope I have the right students here. Yes? Yeah, this is percentage. So this is what I see on my web assign. So if you don't agree with that, you can talk to me. But according to what I see here, Unless I did something wrong there. Let's see if I go back to here. Okay, let me do it this way. I just sorted it. I don't know if I messed it up when I sorted it. But all right, so this is what I see there. So if you don't agree with it, you can come and talk to me about it. Some people's scores are quite low. Okay, so that's not going to be a good situation. Okay? So you should do something to fix it. All right? So please take care of that. And if you need to talk to me, that's fine. But if you want help on understanding it, the first way to get that help is to go to the AMC. If they can't explain it to you clearly, then you can ask me. Okay? So what else do we have to do today? Okay, let's look at some other homework. Okay, so I already told you that we have an exam, right? Did anybody see their score up there, or did I do the wrong class? Did anybody see their score? Yeah, okay. I did the right class. Okay, so we have, let's go to this one, maximums and minimums here. Okay, so let's start with this. So we've sort of covered derivatives now.